Algebra 1 EOC Star Review, Category 1, Factoring and Dividing Polynomials on page 7. Here you see a quick reference you can refer back to as far as how we factor from what we're given. So remember that we can find GCFs. That's always our first step. We always look for a GCF first. If we have two numbers, we can use math num 9. If it's the difference of two squares, so obviously, once again, we look for the GCD first, divide, but if we see a minus, we're going to continue as we take the square root of the first and second term. Remember, we write two sets of parentheses to be able to factor completely. Then also we looked at three terms, a trinomial, and that's when we use our box method. So here were the steps. If you need to come back to refresh your memory, you can rewind this video and look to see how we factor. So let's get right into some examples. So this first example is two terms. So the first thing I'm thinking is, do I have a GCD or a greatest common factor? Well, that's 1 and 25. So the GCF would be 1, means there's nothing in common. So the second thing I would think is this is probably the difference of two squares. It's definitely the difference. X squared is a perfect square because x times x, and I can take the square root of 25. That is also a perfect square. When we write the difference of two squares, we write two sets of parentheses, one plus, and the other needs to be a minus because a positive times a negative gives us our minus or our difference. The second example is a trinomial, so we would use our box method here. We multiply the first 4 times 9 to get our 36, and that's our calculator steps. Y equals 36 divided by x, and y2 we type in 36 divided by x plus x. This will help us find the rest of our boxes. Remember, in our table by second graph, we're looking at the last column to equal the middle term. So looking back at my trinomial, my middle term is negative 12. So my combination here would be negative 6x and negative 6x. With those, now I can fill in all four boxes. 4x squared is its only like term, so we bring it into the first box, and the positive 9 goes in the last box. Now we know that negative 6, using our calculator, we found goes in the two other diagonal boxes. Now we need to find the GCF of our top row, 4 and 6. The GCF is 2. And also x squared and x, the GCF is x. Well, 2x times 2x, I'm multiplying outsides to get the inside. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x, and the same on the top. So when my shape here has is four sides and has the same side lengths, I know that this is a perfect square. 2x minus 3 times 2x minus 3 can be rewritten as 2x minus 3 squared. Third example is also a trinomial. We start it the same way, multiply the first times the last, so 4 times negative 5 is negative 20. And you see the calculator steps there, what we type into our y equals screen to help us out. And then we go to second graph, and in our table, remember we're looking for the last column to equal the middle term. Well, here the middle term is just positive x. We know that's an understood positive 1x. So we're looking for the last column to be 1, and we see the combination is positive 5 and negative 4. So now we're ready to come over here and enter our, write in our four boxes. The GCF of the top row is going to be a 4x. 4x times x is 4x squared. X times positive 5 is 5x. And then 4x times negative 1 is negative 4x. You can always check the last box to make sure positive 5 times negative 1. Yes, that is negative 5. So we would write our factors as 4x plus 5 times x minus 1. This next example is a binomial divided by a monomial. So this is a don't break my heart strategy that we've used. So we would do 16x to the 7th divided by 4x. And then we would take the second term, negative 36x squared divided by 4x. So 16 divided by 4, I know is 4. And then with the variables, we looked at this division law of exponents earlier. That's x to the 7th divided by x to the 1st. The division law, remember, tells us that with like bases, we can subtract exponents. So I would get 4x raised to the 7 minus 1. And the second problem I have is negative 36 divided by 4 is negative 9. X squared divided by x to the first. Remember, we subtract exponents, so we should get 4x to the 6th minus 9x. The next example is nice in the fact that it's already been factored. It's already in factored form for us. So we look to see if we can simply cross out top and bottoms in common. X plus 8 divided by x plus 8. Anything divided by itself is 1. So we're just left with the remaining 3x plus 5. This last example, a little work to do here. The bottom, x minus 2, I know I can't factor that further, but this top is a trinomial. So we will have to use the box method to factor that. So we multiply first times last to get 70. Remember, we put that into our y equals screen, 70 divided by x. And then y2, we would do 70 divided by x plus x. We then go to our table and we look for the y2 to be the middle term, the negative 19. And you should have found that occurs at negative 14 and negative 5. Now that all four boxes are filled in, we can find the outside. The GCF of this top row is x. 7 and 5 are prime numbers. The largest thing to go into both of those is just 1. So x times 7x would give me the first box as 7x squared. 7x times negative 2 is negative 14x, and x times negative 5 is negative 5x. So my factors are 7x minus 5 and x minus 2. If I bring that over, I now said the bottom is already factored. I have now factored the numerator or the top, and now I'll look to cross out any that they have in common. X minus 2 in common in top and bottom, so I cross those out. So I'm left with 7x minus 5.